And we're live? Probably. Cinnamony's in my Discord doing stuff. I'm kind of curious as to what he's on about. But more importantly, let's get chat running. And we're live proper. Let's go. Okay. Yes. Yes, let's go. Alright, so hello, yes, it's your girl Double Koi. I'm up to something a little bit different. It's not going to be a game per se, it's more like game making. We're still technically playing a game, but this time it's a little bit different. Hold on. Been meaning to do this for ages. Gee, thanks. Okay, speed and acceleration are now things that I can mess with. Well, maybe I shouldn't make acceleration and export. I still want to be able to determine the dog's speed, though. And by dog, I mean that neat little ball right over there. It's going to be fun. Chat running? Chat is running. Sweet. So, in a nutshell, I've been developing this game on my downtime between streams and work, but the problem is between streams and work is a very short window of time that I should be spending taking care of myself. So I think I'm just going to stick this into the stream hole instead. That seems like the way. Jesus. Yes, we all know that Jay Schlatt killed the queen. He was in England when it happened. Jeez. But anyway, this game's actually pretty simple. I got some tiles that I can mess with. It's a pretty simple tile set that I used to build this whole dongle out here. And I'm probably going to be expanding this today. Mostly I just made a huge courtyard full of pillars to test my movement and the little ball's movement. And right now what we got here is... I'm not sure if y'all can see this. I'm going to wait for my stream to catch up to see if y'all see this. But we got me. Oh, that's another thing I should probably fix is clamp how far I can look up and down. Maybe in a moment. Okay, sweet. We can see this. So I got me. I can move around. And the ball can move around. And the ball can sort of chase me through this little maze. And also, it took me ages to get it to happen properly instead of the ball just sort of like floating away. But now when the ball gets close enough, it actually stops. And I think that's really cool. I should also probably figure out what's causing that weird stutter. But yeah, that's what we're up to right now. What I do want to do is mess with the character a little bit. Actually, hold up. Yes! The speed is changeable. Swiggity sooty. Okay. I want to mess with you. Export constant. What? Does it have to be a var? Does that break anything? No? Okay, sick. Export. Now, I don't actually remember if I have a jump button yet. Maybe. Delta, if not, is on floor. Do the gravity. You see it? Sweet. It's all working out. Now, there's not going to be any sound except for my lovely, sweet voice, but I hope that'll be fine. I also have no idea how many spoons I have for actually messing with code right now, but we're about to find out. I want to change that. How do I change that? I vaguely remember how to do that. Project settings. I think it's this. Input map. Here we are. Add new action. Jump. Oh, UI accept is already space. But I don't want it to be UI accept. I want it to be jump. Because like that also means it jumps whenever I hit enter, and I don't want that functionality. UI right, up, down, page up, page down. Jeez, it just keeps going. I'm gonna turn that off now. Add a jump. Space. Sick. My nice little librarian voice. I don't sound like a librarian, do I? Close. Okay, so now I should be able to just change this to jump and it'll work. Yeah. Input is action, just press jump. Should work. I also want to mess with the brain work with me. I also want to mess with the comments on this so that it tastes a little bit better. Just a bit. So I will spend some time doing that. That's fine. Lucky for me, the Godot 4.2 came with this script, and I can just sort of mess with it a little bit. Like, I could unironically make a character, and when I'm making a script for a character, there's an option to just generate a move script. So it was really easy getting a pill to move, which is great. I love this. This is way better than Blender? No. Blender used to have a game engine. I'm thinking of Unity. That's the one. God bless Unity, but fuck Unity. Function unenabled input. What are you doing? Oh. Okay, so that's basically what this whole thing does, I think. Like, this one looks for an input that hasn't been handled yet. It checks to see if I've clicked the screen. If I have, it locks the mouse and starts reading it for the purposes of, like, looking around. Embrace the librarian vibes. Fine. What is this sorcery? This is GDScript. I don't understand it either. Don't worry, I'm putting in comments so it'll make at least a little bit of sense. So, I want to hit enter here. Mm-hmm. I really should make an exported variable for this thing so that I can increase and decrease the brain work with me. So I can increase and decrease the sensitivity. I should also look up how to how does I put it? Lock the cameras up and down so that it can't pass. There's a way to clamp that, I'm sure. I forgot. What is this? Sorcery. Opinion on camels. The camels are a lie. Those humps don't carry water, they carry meat, and that meat is a delicacy, and I want to try camel meat. But they're a lie. That's my opinion on camels. They're a filthy, dirty lie, and I'm surprised nobody found out until recently. Okay, so add the gravity, handle jumping. I'm probably going to leave that because that's just true. Let's see here. Input, get vector, those things, direction. And this moves the character based on which way my neck is looking, and neck is up here. It's the thing holding the camera. I think I declare the neck up here somewhere. There you are. Oh, what else do I want to do? This is sorcery, then is she declared a witch? I am a witch. I'm declaring myself as a witch. Look at me go. I barely understand what I'm looking at, so I'm not entirely sure if I can really... I guess I could put some comments in here, but it's a little bit weird. I'm actually going to replace both of these. I'm back. You want to eat camels? Yes, camel hump meat is a lie. There should have been tanks of water up there, and they're not. And now I want to see what camel meat tastes like since I can't drink camel water. I'm not taking that back. That's so cursed. Brenda Witch, you know a lot about camels. You live in Africa. Hey, yo, I forgot. Also, hi, how's it going, Dr. Socks? Alright, brain. How do I lock the camera so that this doesn't exactly... I think I have to do it here. Okay, so the X should be able to spin forever. But the Y should be able to stop at perfectly vertical. Like I need to lock the camera so that it goes up until you're looking straight up and then it stops you, and then down the same way. Also M. Where? Oh, you removed it. Typo, I guess. How do I do that? Oh yeah, fair warning. I don't know very much about GDScript. I want to look at 3D for a moment so I can figure out... Yeah, if I'm looking up, it's rotating around X. Okay. So, you. Camels also aren't found in South Africa. You lied. Oh. You lied to me. Alright. You don't know anything about coding either. It's alright, because I can hold control and then I can click something. And it'll tell me everything about that specific dongle. Wait, am I rotating around the X? Yes, I am. So I gotta do it to this one, and I don't entirely know how. Another thing I also want to do is add export var. Okay, so now I can change both of these. Rotate this by sensitivity. And now if I go into 3D and I click the character, you can see the sensitivity right there. And I can change that. So I actually want to cut that in half because it's as 0.5. There. It's a little more manageable, but it's still weird. What if even further beyond? Oh, okay. So the third decimal is the lowest it gets. So let's see if this works a bit better. I feel like that's a lot more manageable. Sick. Also, this hoe has normals. I'm so proud of my normals. You have elephants and rhinos? Hey yo, I heckin' love elephants. All that code looks absolutely repulsive. Too many letters. It's definitely weird for sure. Lions and hyenas and leopards and cheetahs and buffaloes and baboons. You guys have buffaloes too, huh? Your brain would shut down. Yeah, coding is not for the weak. It is not for the weak. I'm so happy that this sort of acts like Python, although I am not really familiar with Python either. Apparently, it's one of the easier ones to understand. Now then, camera rotate X. I want to get that to stop when it's vertical. How do I do that? You don't know what you call our buffaloes? Oh, you have different kinds. I see. That makes sense, yeah. Hmm. Am I calling you weak? Do you understand the code? I'm gonna real quick go into YouTube. Don't mind my recommendations. I have a whole list of things that help me understand what the fuck I'm doing. I don't think any of it will actually help me because I didn't actually save anything that tells me how to do that. Just gonna have that on the side first. R? Oh. Okay. This is why Google exists. Clamp camera to object, not exactly. Limit the camera angle. Here we go. Somebody already asked this question on Reddit. What are my recommendations? I don't know what you mean. Your buffaloes are like big cows with thick horns. Yeah, that makes sense. Let's see. Huh. Huh. Have I tried dot angles too? This was like 6 months ago. And like the Lion King? I think I know what you mean. Probably. Quaternions, huh? I'm not going to copy paste this. I just want to see what it looks like. Let's see. Hmm. Okay, plate. I see you. The Stampede guys are wildebeests. You're pretty sure? Haven't watched that in ages. Oh yeah, yeah they are. I was also under the impression that that was supposed to be like ancient times where humans don't really exist. Not really exist. Maybe like Neanderthals, but not humans. But I could be wrong. There was never actually any humans or human civilization in that movie. Compute a new quaternion by calling Slurp. That's amazing. This is fucking. This is another language to me. God, what am I looking at? Hmm. You think it's just Disney magic destroying the entire human race? I can see it. What the fuck is that? Transcoding is best coding, you best believe. Continuing the stereotype, the only thing I'm missing are like programming socks. That's it. I have a small duck to tell my problems to. This goofy bastard is great. It's like a weird cross between a duck and an elephant. And then it's got one eye that's directly over the middle of its beak, and then another eye off to the side. I love it. Later, I'll take a picture and post it. Y'all get to see later. Hmm. That's not really what I want. God, I'm having some weird deja vu right now. What are programming socks? Programming socks are socks that are exceptionally comfortable that you wear while you're programming. They give a bonus to your programming powers, so you could do it more efficiently or better. What's the duck's name? The duck doesn't have a name. Hmm. Variable limit floats. The angular limit in radians. That's actually handy. Hold on. I'm gonna disregard that. Everyone deserves a name. Name the duck. I don't have a name for the duck. Or maybe it's an elephant? I'm not sure. I'll post it later with some of the suggestions. We'll see. Rotation basis right there. Dot angle to. Well, I could just beat my head against this until it fixes itself. Should I go deeper into the nested if? Maybe. Camera dot. I think I have to get rotate. No, I probably don't. That rotates around the X, so I need to rotate X. Don't go too deep or you'll never return. You're probably right. Don't mind me, just nest 5 if statements into one little piece of code. It's gonna suck. Okay, let's see. I do want to add to what extent do I want the scope of this? Do I want it specifically in here? I mean, it would delete it constantly if I stop moving, though, so I don't want that. This is also going to be updating whenever I make an unhandled input, so maybe I should put it up here. Okay, so now we have an angle, which is a float. Wait, can I decide what kind of a float it is? Expected end of statement after variable declaration. Darn. Okay, so I can't just decide that. So what the heck is this supposed to do? Floating point numbers. I think that's... Yeah, that's these. Alfred Trumpet Nose? It doesn't even have like a... It's got a beak. It doesn't have like a trunk or anything. Yeah. Maybe I'm looking at the wrong one. Limit camera angle to what? How do I word this so that how do I word this so that the algorithm understands what I need? Where does it keep its luggage? What luggage? Homeboy lives rent free on my desk. He doesn't really own anything. I'm not sure if he's a pet or a roommate at this point. A little of both, really. I'm trying to prevent the camera from going upside down. All right, I'll be right back. Need to use the bathroom. Shrunk. Oh, that's a joke. I see. I'll be right back. Stare at my code. let's get back to it. What do we use to refer to the trunk in our car then? I mean, we just call it trunk. Unless you're talking to Dr. Socks. I don't know what Dr. Socks would call it. Alright. Alright, Alfred Trumpet Nose. I'm trying to get my camera to not rotate forever when I look directly up, so that my head doesn't bend all the way backwards and I can look behind myself. And I want to make sure it does the same thing when I'm looking down as well, so I don't, look too far down. Hold on. I'm going to open this real quick. I feel like there was something in here that
Full Sail University's art and design programs embrace design practices built around emerging technologies.
Skip.
Verb.
Thanks, babe. Okay, let's see. More. Intro. Input variables if statements. Is there something for clamping? Variable 1.0, variable 2.0. Here we go. Gonna look at this.
An error. Variables 2.0. When creating or declaring a variable, we need to think about where we do so. If we declare a variable inside of an if statement, for example, we can only use that variable inside of the if statement. This is called scope, and is something that beginners often make mistakes with. If we want to use a variable in many different places in our script, we make sure to put it at the top, outside of any functions. So this is a script-wide variable. This can be accessed anywhere in your script.
Yeah.
If you were to declare it inside of a function, you would only be able to use it in that function. So this is a variable we can only use in ready. Now, a really cool thing about variables in GDScript is that you can declare them without thinking about what type of data is inside them. Here's a variable that is either true or false, and here's a variable that stores a number.
Do you ever tell me how to clamp?
As you can see, they're created in the exact same way. In fact, we can even change the type of data that they hold just by reassigning them. So we can actually set our coolness to true, and this runs completely fine. That being said, we still need to be aware of what type of data we're working with, because some parts of our game will expect a specific type of data, and we will get an error if we try to use another type without converting.
Right.
Now, in GDScript, we have the 4 classic data types: Boolean, or bool, for true and false; integer, or int, for whole numbers; float, for numbers with decimals; and string, for text. Converting from one type to another is called casting. For example, we can cast an integer into a string. So if you have a number that is equal to 42, we have some text, which is a string. Well, then we can add the number to this text, but we convert it into a string by writing str for string, and then the variable inside of the parentheses. And if we print this, it works fine. We can do a similar thing to, say, convert a float into an integer. So if we have a variable called pi that is equal to 3.14, then we can convert this into an integer by going int pi, and let's print this. And it prints 3, a whole number. Note, however, that this automatically truncates the number. It does not round. It simply gets rid of the decimals. So 3.9 also results in 3. Some other data structures that are really common in GDScript are vector 2 and 3. Vector 2 stores 2 floats, x and y, and vector 3 stores 3 floats, x, y, and z. These are most commonly used for positions, so I can create a variable called position with some coordinates. I can then modify one of the components, so position.x plus equals 2 adds 2 to the x component, and then we can print the whole thing. And this gives a vector 3 of 5 minus 10, 5. Now, by default, GDScript is what we call dynamically typed. This means that we don't define what type of data a variable can hold when we declare it, which we've been using so far. This makes it fast to create variables and flexible because we can reassign data of another type at will. However, it is also more prone to error and less performant than static typing. Luckily, GDScript allows us to statically type any variables we want. We can pick and choose totally based on preference. To statically type a variable, we simply add the type when declaring it. So here, if we have a damage variable, we can specify the type and then set the value. So now this variable will always stay an integer. We can even have Godot automatically determine the data type by simply writing colon equals and then the default value. This is called inferred typing, and the result is exactly the same. The type is still static. Godot simply recognizes that 15 is a whole number and sets the variable to a type of int. This also means that the variable cannot change to another type. If we try to set it to a string, we get an error. Now, adding export in front of a variable will allow us to set it using the inspector. The value that we set in the script will just be a default value. So if we save this and select our node, we can set a value in the inspector. If we print our damage, we can see that this updates in our game. And we can always press the circular arrow to revert back to the default. Now, sometimes you want to define a variable that cannot change. For this, we use constants. So I'll write const for constant. We'll call it gravity. As you can see, it's standard practice to name constants with capital letters. And we'll set it equal to negative 9.81. Now, we can use this like any other variable, but we cannot change it. If we try to do that, it throws an error. And that's it for variables. Great job. Functions.
That doesn't help. Okay, let's see. Let's see if this one is what I'm looking for.
And we're back. The team is looking down the barrel of a 4:55 meeting.
Can they turn it around?
Already done that, right? That doesn't help. That doesn't help. Ah. Maybe this one. Let's see if this one tells me.
At Fiverr, we offer 3D rendering
This
services.
was a year ago, though.
But you
I had
you
forgotten
probably
mine.
are.
Hello and welcome back to the channel. Today we'll be making a complete first-person character controller from scratch with a bunch of features to enhance the game feel, also known as game juice. These features will include head bob, inertia, and movement FOV change. So let's dive right in. We're going to create a new 3D scene and call it world. For our ground, we're going to use a node called CSG box, which is basically a simple mesh combined with a collision shape that's good for prototyping. Our character is going to use a node called character body 3D. We're going to add a mesh to it by choosing the beam shape in the mesh dropdown. We're going to create a collision shape from the mesh by going to this menu and selecting create simplified convex collision sibling. If we turn off the visibility on the mesh, we can see that we end up with this disheveled beam that has less vertices than the original, which is good for performance. Let's add a script to our beam. Character bodies get a default code template with movement and jumps implemented, which works well for both first-person and third-person controllers. In order for the lighting to work properly in our game, let's add a world environment and a directional light to imitate the sun to our scene tree. Let's take a closer look at our beam. The last bit of setup we need to do is adding a camera to him and adding it as a child of a node 3D, which will act as our pivot. If we don't have one and try to rotate the camera, we get some very janky results. If you're curious as to why this happens, I will link to a page in the Godot documentation that explains it really well and also has a code snippet that would let us do it without a pivot. Now, if we start up our game, we are able to move around and even jump out of the box, but we can't look around just yet. So let's get cracking on our code. We have the speed and jump velocity constants here. The gravity variable is taken from the default project settings, which is 9.8. Screw that, it's now 9.8. In the physics process, we handle our jump. When the player presses space, we set the velocity so we're going up, and then every tick we lower this velocity if we are not on the floor until the velocity is in the negatives and we are going down. At the end of each tick, the move and slide function is called, which moves around our character depending on this velocity vector and then changes the velocity depending on collisions. So when we're about to land, our y velocity is negative 4.5 and then bam, it's 0. And it stays at 0 because we are now on the floor and are no longer changing it. This last code block takes care of movement on the floor. It tells us that we should replace the default UI actions with our own, which we will do in a second. Here we get a vector 2 movement vector from the inputs and change it to a vector 3 so we can multiply by where our character is facing, which gives us this movement direction vector. If it's non-zero, which means that we pressed a button, we set the velocity components by multiplying the direction vector by our speed. This next part has a bit of a mistake in it. All the actions that we want to use in our game and setting bindings for them. We add our new actions to the code and then see what we need to do. Multiplied by the sensitivity, which we're going to add as a constant. Here we're keeping the rotation axes separate, so we're only rotating the head on the y-axis and the camera on the x-axis to avoid the whole rotation order mess. You'll also notice we're rotating the head y-angle depending on relative x distance. This is not a mistake, but rather just a byproduct of how translating mouse movement to camera rotation works. When we move the mouse left and right, we want to rotate around the y-axis, which is pointing up, and when we move the mouse up and down, we want to rotate around the x-axis, which is pointing to the side. So after putting all of this together, we can finally look around. Our sensitivity might be a little too high, and also we can do cartwheels with our head. So let's use the clamp function, which can limit the rotation of our camera to a min.
Ha! That's the noise. There's a camera. Okay. Or there's a clamp function. Gotcha.
Minimum and a maximum value. I'm also getting tired of staring at a white floor with nothing on it, so let's use a bunch more CSG boxes with different color materials to create a map. Much better. The last thing we need to fix with the basic movement
Okay. Rewind it a bit.
axis, which is pointing to the side. So after putting all of this together, we can finally look around. Our sensitivity might be a little too high, and also we can do cartwheels with our head. So let's use the clamp function, which can limit the rotation of our camera to a minimum and a maximum.
Okay, so we're clamping rotation X to some numbers. I'm gonna go play with that now. Let's see. So we don't need an if. We for sure do not need an if. I'm not going to give it an if. So camera rotation dot x give it clamp. Let's see. So it looks like clamp, it's the camera thing, and then the 2 degrees up and down, I'm guessing. Camera rotation X angle stuff. Yeah. I'm going to make them both 60. Degree to rad 60. Does that make sense? Okay, great. I'm going to hit play. Okay, so I can sort of look up and I can sort of look down. Sick. I'm going to make that 90 now. Okay. I swear if that's all I had to do. Is that actually all I had to do? Yep. Okay, so that works, and that works. Swiggity swooty. Alright. Play with me for a second. Time to do something that doesn't suck ass to do, and I don't need the internet to find out about. I'm gonna go to Real Floor 3D. Go to Grid Map. What? Grid Map. Take some wall. The fuck is this? It's not F. Here we go. Take me some floors, stick those right there. Oop, that's not what I wanted. I need a wall. So I made that one 4 long. That means I'm going to make this one 4 long. Okay. I'll just make pillars for the corners. Okay, so how long are you? You're 2, 3, 4, 5, 6, 7, 8 by 8? No, wait, that'd be a 16 by 16, huh? One, two, three, 4, 5, 6, and then corner. So you should be a corner. I'm also going to make these floors. Let's see. So corner 2, 3, 4, 5, 6, 7. So 14 of those, huh? 1, 2, 3, 4. 14. Corner. Wall. Ah, yes. It's all coming together. Corner. Wall. Sick. And then the rest of these get to be floor. Very simple little courtyard that I will use to test combat. In a moment, once I figure out how to make items and stuff. Well, I guess first I should actually establish using items. Or at least using combat. Doing a combat. Gotta do a big fight, which means I need to make an enemy that will actually, like... Well, quote enemy. Enemy in quotations. Okay, save that. Now over in lab test, there should be that thing. Swiggity sooty. Oh, that means I need to I need to rebake this, huh? Alright. Clear the nav mesh, bake the nav mesh. Sweet. Now Forstet can follow me into that room, theoretically. So I'm gonna hit play. Alright. Hello, Forstet. It's nice to see you again. You're behaving normally. Gonna run into this room. And you're gonna follow me in. Swiggity swooty. Alright, it's all working out. I can even jump out here. Hey, yo. I forgot jump exists. I can stand on you. Oh, you're so adorable. You're still trying to actually chase me. I suppose it doesn't exactly have the power to, like, jump. So, whatever, it should be fine. Okay, that'll be good enough. I think what I'm probably gonna need is probably an enemy. So I'm gonna, this is a 3D, add child node. Wait, hold up. Before I bother with that, what the heck is Forstet? Forstet's a character. Character body 3D. Add child node mesh. I think there's a way to establish what the mesh is. Forced edit. Okay, yeah, gotcha. So mesh. Gonna make it a box. Hello, box. Gonna make it a slightly taller box. Good. In retrospect, I don't know if I need it to be this massive, so yeah, that should be good enough, probably. It's really just a stand-in until I start making like actual models. I just need an object to look at while I child node collision. What are you? Shaped spear. It's neat and all. Character collision shape. Convex polygon. I should probably make you the same. But I want to leave it that. Now, how did I set you up? But if I go over here and I look at this guy, yeah, you actually have a shape. So you should too, but why not? How did I do this last time? Oh no. God, it's been ages since I've done it. No. Can I just... Wait, did that actually work? Yes. The answer is yes. Okay, sick. This is a punching box. Say hi, punching box. Alright, so Called when the node enters the stain tree for the first time. Called every frame. Okay, well, I don't think I'll need the func ready, so we gonna get rid of that. Let's see. I want an export. I don't know, we'll make it 50 for now. Oh, I need to name you. Okay, health is now 50. It has to be an integer. Let's go. How do I want to do this? I'm gonna make... I'm gonna make a health script, like a punching bag that can receive damage. That's basically it. But how do I want to do that? Over in 3D, I can look at this and I can adjust the health, which is sweet. But how do I transfer damage in Godot? That's a good question. Hold up. I have YouTube videos for that. Hold on. Let's see. Back up a little bit further.
Variable times 100.
Shut.
Inheritance and composition are two tactics used in programming to reuse your code as much as possible. Inheritance is very widespread, but I think there's a lot of times where composition would fit a little bit better. Let's say we have this setup. We have a player, and this player can attack, has health, and a hitbox. Alongside that, we can accept user input. And similarly, we have an enemy. This enemy can attack, has health, and also a hitbox, as well as some enemy-specific stuff like AI. In the world of inheritance, we would take the attack, health, and hitbox and drag them out to their own individual class. We'll just call this class entity, and the player and enemy will extend from this class. This moves all our code into one easy-to-change spot, so if we ever have to modify the code, it'll affect both the player and the enemy at the same time. We don't have to go digging through every class that has the ability to take damage. And if that were the end of the story, inheritance would be the perfect solution. I mean, right now, this is really easy to comprehend. But let's bring in another object. Let's say we have a tree, and similar to the player and enemy, the tree can take damage. So we can extend entity, but this causes a small problem. While we do have the health and the hitbox, now we also have the ability to attack, which we probably don't want from a tree. There's also a more potent underlying issue. Because we're using Godot, both the player and the enemy extend character body 2D, whereas the tree extends static body 2D. In the world of inheritance, at least in Godot, you can't extend from multiple classes. Since player and enemy both need their own character body 2D code, entity must also extend character body 2D. However, since tree also extends from this entity class, that means it must also be a character body 2D. There's a few ways around this, and the most straightforward approach is to change tree from a static body to a character body. This isn't ideal though, because this gives the tree the ability to move. Alternatively, you can extract the entity class out into a static entity and a character entity and decide which classes need to inherit from where. But as you can see, this is already getting a little bit complicated, and all we did was add a tree. There's gotta be something better. Let's rewind a bit. Instead of using inheritance, we'll approach this with composition. Instead of making one superclass, you instead make multiple components. So for example, we would have an attack component, a health component, and of course a hitbox. Then the player and enemy would both just have their own list of components that they need. In this case, we have 3. Let's bring back in the tree from the earlier example. Because components don't care what class you're extending from, we can simply attach a health component and a hitbox component to the tree, and we're done. That's all the hierarchy we gotta worry with. You can see in this case, this is a lot more preferable to inheritance. And there may be a few odd things like telling the hitbox component where your health component is so it can
Okay,
send
but
information about
where
taking
do I
damage.
do
But
that?
I think that's a valid trade-off. In Godot, each of these components would actually be a child of the player, enemy, or tree node, and you can arbitrarily attach them to any node that you feel needs these components. So for example, let's say we bring in a bullet. Well, for the bullet, we want an attack component, but we also want a hitbox component. It doesn't matter how much HP a bullet has. If it hits something, it's going to destroy itself, so we don't need a health. This is the basic idea behind composition. Let's go ahead and jump into Godot, and we'll build through a project where we use composition. All right, back in the project from last video, I've gone ahead and removed any reference to the damage functions from before. I want to build back the damage functions from before, but using composition as a base. First off, I'll add a new node 2D to the enemy and call it health component. I'll also add a new script to this. Starting off with the script, we'll add a new health variable, a max health, and inside of the ready function, I will set health to max health. Then I'll add
Okay, well that is important.
damage function and take an attack from last video and subtract that damage from the health. Then if the health ever drops below 0, the parent will free itself. Back on the enemy, we'll add a new area 2D object and call it hitbox component. You may notice a warning and subtract that damage from the health. Then if the health ever drops below 0, the parent will free itself. Back on the enemy, we'll add a new area 2D object and call it hitbox component. You may notice a warning about the shape, but we'll get back to that later. We'll attach a new script to it. We'll start by exporting a health component variable, then add a damage function, also passing an attack like before, and then we'll check if the health component exists. If it does, we will call .damage on it. And the health component variable can be set in the inspector, like so. One thing I don't really like about this is we can attach any node 2D to this health component variable. And for example, if I attach the sprite 2D, this would crash because sprite doesn't have a damage function. So instead, one thing we can do is inside of the health component, we can declare a class name health component. Then instead of just using any node 2D, we can specify that we want specifically a health component. Then inside of the inspector, you can see that it only highlights things it classifies health.
Okay, let me slow this down so that my brain can actually, like, simmer on it. Go back to being normal.
And take an attack from last video and subtract that damage from the health. Then, if the health ever drops below 0, the parent will free itself. Back on the enemy, we'll add a new area 2D object and call it hitbox component. You may notice a warning about the shape, but we'll get back to that later. We'll attach a new script to it. We'll start by exporting a health component variable, then add a damage function. Position. Alright, back in the project from last video, I've gone ahead and removed any reference to the damage functions from before. I want to build back the damage functions from before, but using composition as a base. First off, I'll add a new node 2D to the enemy and call it health component. I'll also add a new script to this. Starting off with the script, we'll add a new health variable, a max health, and inside of the ready function, I will set health to max health.
Okay, so back to this. Punching box doesn't need this thing. Goodbye, punching box. However, I'm probably going to also need on ready, so... Where are you saving the script? There. Okay. So now we have a function ready. I'm just going to leave that alone for now. Trunk in the car can be called a boot. That feels weird to me, but okay. Seems legit.
Position. Alright, back in the project from last video, I've gone ahead and removed any reference to the damage functions from before. I want to build back the damage functions from before, but using composition as a base. First off, I'll add a new node 2D to the enemy and call it health component. I'll also add a new script to this. Starting off with the script,
Just need to node 3D. Add a script to it. Okay. What?
We'll add a new health variable, a max health, and inside of the ready function, I will set health to max health. Then
Good.
I'll add a damage function and take in an attack from last video and subtract that damage from the health. Then, if the health ever drops below 0, the parent will free itself. Back on the enemy, we'll add a new area2D object and call it hitbox component. You may notice a warning about the shape, but we'll get back to that later. We'll attach a new script to it. We'll start by exporting a health component variable, then add a damage function, also passing in an attack like before,
Right.
and then we'll check if the health component exists. If it does, we will call .damage on it. And the health component variable can be set in the inspector, like so. One thing I don't really like about this is we can attach any node2D to this health component variable. And for example, if I attach the sprite2D, this would crash because sprite doesn't have a damage function. So instead, one thing we can do is inside of the health component, we can declare a class name.
Class name. Okay. There. So this is a health component. And we're going to establish what exactly a health component do. Alright, so alright, swiggity swooty. So now there's a max health. You also have float.
Health component. Then instead of
health
just
is a
using any
float?
node2D, we can
Excuse me?
specify that we want specifically a health component. Then inside of the inspector, you can see that it only highlights things that classify as health components. This is also nice because this gives us IntelliSense. So if I do control space inside of this function, we can see what it expects. Or if I control click damage, it will take us to the declaration. Let's go ahead and save these off what it
Wait.
expects. Or if I control click damage,
Okay. Okay, so you have damage on the health component, I see. Var health is an int. Okay, so health. So let's see. At ready, health equals. Good. And they have a function damage. Okay.
it will take us to the declaration. Let's go ahead and save these off to their own branches as health component scene and hitbox component scene. One thing you may run into is if you previously assigned the health component and you go into the hitbox component scene, you'll see that it's already pointing towards a health component. You can leave this if you want, but it may cause issues in the future. So I usually just clear this and assign it for every enemy that I create.
Okay. Could not find attack. All right.
All right, let's talk about this more,
Why
but
not?
we'll get back to that later. We'll attach a new script to it. We'll start by exporting a health component variable,
Right.
then add a damage function, also passing in an attack like before, and then we'll check if the health component exists. If it does, we will call .damage on it. And the health
You have an attack script. I see. Okay. So that means I should also have an attack script. Wonderful. God, this is getting a bit messy. How do I want to make an attack component? Posted a year ago.
Component variable can be set in the inspector, like so. One thing I don't really like about this is we can attach any node2d to this health component variable. And for example, if I attach the sprite 2d, this would crash because sprite doesn't have a damage function. So instead, one thing we can do is inside of the health component, we can declare a class name health component. Then instead of just using any node2d, we can specify that we want specifically.
Okay, neat. So I should add a child node. I guess the add script is here. Hitbox, check, create. Need a function process.
A health component variable can be set in the inspector, like so. One thing I don't really like about this is we can attach any node2d to this health component variable. And for example, if I attach the sprite 2d, this would never drops below 0. The parent will free itself. Back on the enemy, we'll add a new area2d object and call it hitbox component. You may notice a warning about the shape, but we'll get back to that later. We'll attach a new script to it. We'll start by exporting a health component variable, then add a damage function, also passing in an attack like before, and then we'll check if the health component exists. If it does, we will call .damage on it. And the health
Okay.
component variable can be set in the inspector
Wait.
position.
You
All
did
right,
something
back in the
weird
project
with
from
the-
last video,
okay.
I've gone ahead and removed any reference to the damage functions from before. I want to build back the damage functions from before, but using composition as a base. First off, I'll add a new node2d to the enemy and call it health component. I'll also add a new script to this. Starting off with the script, we'll add a new health variable, a max health, and inside of the ready function, I will set health to max health. Then I'll add a damage function and take in an attack from last video and subtract that damage from the health. Then if the health ever drops below 0, the parent will free itself.
Well, this homeboy probably has an attack video, so... Video. Looks like it's this one. Fix TF2. Yeah, fix TF2. 100%. But let's be real. I don't think Valve will give a shit if we review Bomb TF2 or not. I mean, we could totally try. But ultimately, the only way to actually fix TF2 is to hit Valve right in the wallet. So if you really want to do it, we're going to have to push like a boycott for trading. It's only so long before the players start doing something besides peaceful protest. Nah, it's probably going to stay peaceful. I don't know what you're on about. Okay, so this...
Did you know that Godot has the ability to create custom classes? These are useful scripts that can hold variables and even functions, and can make your code more readable and extensible, leading to less bugs and more productivity. In this video, I'll be adding a feature to a small project and show how classes can make this process easier, more streamlined, and less error-prone. As always, use the timestamps in the description or chapters in the video to skip the parts that you care about. I'll be using the Sproutlands asset pack by Cup Nooble. Link is in the description. So here's how the game stands so far. We have a character that can walk around, and when we click, she attacks in front of her. We also have this cow that can take damage and eventually die. The damage is handled like so. The weapon checks if the body it hits has a damage function, and if it does, it calls it, passing in its attack damage value. And inside of the enemy, we have the damage function. We subtract the damage from the health.
Back up.
And inside of the enemy...
Back up further. A little bit further.
The damage is handled like so. The weapon checks if the body it hits has a damage function, and if it does, it calls it, passing in its attack damage value. And inside of the enemy, we have the damage function. We subtract the damage from the health, and if it hits 0, it deletes itself. Now, I want the ability to knock the damage from the health, and if it hits 0, it deletes.
I see. So, health component. Less than or equal to 0. What was that line of code? Q free? Does this make sense to you, game? Sick. Okay, let's proceed.
Itself. Now, I want the ability to knock the cow back whenever we hit it, which we can go about in a few different ways. We'll start with the straightforward approach, and then go over some problems it may cause and a better way to do it later. First off, inside of the weapon, I'll add a new variable called knockback force, and we'll pass that into the damage function. We also need to know where the attack comes from, so we'll also pass in the position of the attack. Then, inside of the enemy script, I'll modify the damage function to take in these new parameters, and just apply a velocity change in the opposite direction of the attack. If I go back into the game, all seems perfect. So where's the problem? Well, there's something I didn't mention. We actually also have these trees and crates around the world that we can also break. And since we modified the damage function, if I try to hit them, the game crashes. That's because we haven't changed the tree and crate functions to take in these new parameters. To fix this, we'll have to go into the functions and add the new parameters to both the tree and the crate. Unfortunately, even though we have to add these parameters, the tree and the crate don't actually care about them. But because we changed what we're passing in here in the weapon, these have to have these parameters, otherwise we get a crash. I will say, if you have a small project and you're unlikely to change the damage function, this can be perfectly fine. But let's imagine you had 20 different scripts, all who do different things with the damage function. This can lead to a lot of complexity and issues down the line, and it can just be annoying to change these functions. So what can we do better? Let's start by adding a new script. I'll just call mine attack.gd, and I'll start with class name attack. What this class name does is it allows any script in the project to reference this attack.
Okay, we're actually making
this can lead to a lot of
an
complexity
attack.
and issues down the line, and it can just be annoying to change these functions.
Yep.
So what can we do better? Let's start by adding a new script. I'll just call mine attack.gd, and I'll start with class name attack. What this class name does is it allows...
Did you just make a new script? Ah, okay. So you have like a whole script folder. Where are all of my scripts anyway? Folder scripts. Scripts for stuff. Let me just real quick digging through all of my stuff so that I can find and move all of the scripts. Okay. U3. Go into scripts. Hopefully that doesn't break anything. Theoretically that doesn't break anything. If it does, oh no. Anyway, scripts. Alright, so attack. Sick. I don't think I need ready, but I'll just leave it here just in case. I for sure don't need process. Okay, so over in health component, it doesn't know what attack is. But we're working on that.
I'll just call mine attack.gd, and I'll start with class name attack. What this class name does is it allows any script in the project to reference this attack class. We'll get into that more later.
Okay, so you need to be save as. You need to be capitalized. Save. Yep. Okay, sick. Health component. You sort of know what attack is. Attack exists, I promise.
But for now, I'll just add 3 variables. These are attack damage, knockback force, and attack position. We can also assign these a default value if we want, but I'll just keep mine blank.
I don't intend to really add knockback just yet, but I'll do that in a moment. So, let's see. Which is an integer. Sick. So now attack has an integer. I'm gonna save that real quick. And that should be something I can just change Maybe. Although he made it a float, I don't really feel like making it a float.
That's actually all we need for this file, so I'll go back to the enemy script, and instead of passing in these 3 parameters, I'll instead pass in one attack object, which I will annotate with type attack. Annotating it as attack gives us 2 benefits. This allows us to use autocomplete, and if we try to pass anything that isn't an attack into this function, the game will throw an error, and so we're guaranteed that the only thing passed into this function will be an attack. Of course, right now the function has errors, so instead of referencing the old variable names, I'll instead call attack.attack damage, attack.attack position, and attack.knockback force. Going back to our weapon class.
That's awesome. Okay, we're halfway there, boys and girls. I'm gonna go use the bathroom again. Be right back. Stretch your legs and stuff. Also, all of the stuff that I'm looking at, I'm gonna leave it out of full screen so you can look at the name and like the name of the person who's making it. If y'all want to make games, you should totally do that too. This is what I'm looking at. I have like an entire chunk of game tutorials like right here. This one especially. This one and then where to go? All the nodes. Both of those are incredible. Like I learned so much from Lucky and Brackies. Y'all should probably check them out. I'll be right back. Maybe like 3 minutes.
we have to change how we call the damage function. Rather than passing in 3 parameters, we'll first start by making a new attack object and assign the attack damage, knockback force, and position like so. And then instead of passing in the 3 variables, we'll instead pass in just the attack object. I'll make a similar change to the tree and crate, and if we go into the game, we can see that everything is still working fine. There's no crash to be seen. And you can see inside of the crate there's no reference to knockback at all. That's because this object doesn't want anything to do with the knockback variables, and so we don't need to specify them here. However, you can see if we call attack dot, Godot will autocomplete and suggest the attack damage, position, or knockback force. This
Neat. Oop, that's not the button. That's the button. Alright, so attack exists. And attack does have... Well, it can have damage. I don't think I'll even need this, huh? Save. Okay, so damage can now be an integer. Swiggity sooty. So attack. I want to take health minus equals attack dot damage. Good. That's basically all I had to do. Okay. Wait. Right.
This means that we can add an arbitrary number of values to this class, and we have to change nothing at all in any of the functions that reference it. But if we wanted to, these variables would show up in autocomplete. To really drive home how easy it is to add something new, I'm going to add something called stun time. This won't actually do anything in the project, but we'll pretend that the enemy uses it. So inside the enemy, I'll add a new current stun time variable and assign it based on the attack's stun time. And then inside the weapon, we'll account for this by adding a stun time. Once again in game, we can see that we can hit the cow, the tree, or the crate, and everything works fine. We didn't even have to touch the tree or the crate because they don't care about a stun time, since stun time isn't relevant to them. Classes can also contain custom functions like this one that can reference the values stored inside of a class instance. These will also show up in autocomplete, and if I call the function when the enemy gets hit, we can see that the function gets called. Hopefully this shows you how useful classes can be if used correctly.
It's pretty
custom
handy.
Functions like this one that can reference the value.
Okay, now that I know what to do, now that I know how to do it, I can probably do all the stuff I need. Oh wait, no. Okay, so that's been done. So I can
Inheritance
go back
and
to
composition
this.
are 2 tactics used in programming to reuse your code as much as possible. Track that damage from the health. Then, if the health ever drops below 0, the parent will free itself.
Right.
Back on the enemy,
Well,
track that damage from the health. Then, if the health ever drops...
oh, that's different than queue free. Okay, so get parent dot queue free. Does that make sense? That does make sense. Okay. Now we got to get a hit. Now we got to get the hitbox to accept attacks and pass that to the health component. Good shit. What does a hitbox need? Hitboxes need... at on ready. Which is a collision shape 3D. No, actually, that's gotta be export. Yeah. So now there's a hitbox, and it has to take this thing. Sick. But I want it to be empty for now, because otherwise it might be a little bit ass. Probably. I keep clicking.
Drops below 0, the
keep
parent will free
clicking that.
itself.
It's
Back
not-
on the enemy,
it's not what
we'll
I
add a new
want.
Area 2D object and call it hitbox component. You may notice a warning about the shape, but we'll get back to that later.
Okay, so maybe that should be a area 3D. No, wait a second. I want to detach the script. Delete that node. Yep. Add an area. Sick. Okay, now what?
There. We'll attach a new script to it. We'll start by exporting a health component variable, then add a damage function, also passing in an attack like before, and then we'll check if the health component exists. If it does, we will call .damage on it.
Okay. Wait, isn't that what I'm doing with health component? Yeah, I am. Okay, so what I actually need is health. I need that to be a health component. It has to be a health component.
And the health
Okay, so it is just regular damage. Gotcha. Good shit. Oh wait, no, this needs some colons. Yes, yes. Sick. That should do it. I think. Probably. Probably.
component variable can be set in the inspector, like so. One thing I don't really like about this is we can attach any node 2D to this health component variable. And for example, if I attach the sprite 2D, this would crash because sprite doesn't have a damage function. So instead, one thing we can do is inside of the health component, we can declare a class name health component.
Good.
Then instead of just using any node 2D, we can specify that we want specifically a health component. Then inside of the inspector, you can see that it only highlights things that classify as health components. This is also nice because this gives us IntelliSense. So if I do control space inside of this function, we can see what it expects. Or if I control click damage, it will take us to the declaration. Let's go ahead and save these off to their own branches as health component scene and hitbox component scene. One thing you may run into is if you previously assigned the health component and you go into the hitbox component scene, you'll see that it's already pointing towards a health component. You can leave this if you want, but it may cause issues in the future. So I usually just clear this and assign it for every enemy that I create. Alright, let's talk about this warning now. So a hitbox needs a shape, and your first instinct might be to put it inside of the actual scene. And while that would work, this means that every enemy and every object that uses hitbox component would have the exact same hitbox shape. Instead, what we'll do, in the enemy scene, we'll actually attach a collision shape as a child of the hitbox component here. This allows us to use unique hitboxes for every single object. Inside of the scene, you can also set up collision through here, or you can do it in the enemy. So for example, an enemy and a player would want different collisions, so you can set it in their respective scenes. And the last thing I'll do is set up my weapon to attack a hitbox. So for this, I'll check whenever we collide.
Okay, back up just a little bit. Gotcha. So I want to make that this.
Respective scene. Inside of the scene, you can also set up collision through here, or you can do it in the enemy. So for example, an enemy and a player would want different collisions, so you can set it in their respective scenes. And the last thing I'll do is set up my weapon to attack a hitbox. So for this, I'll check whenever we collide with an area, we'll check if it has the function damage, and if it does, we'll construct a new attack like before, and call the damage function passing in.
Okay. Okay, that's not hard.
The attack. We can also do something neat with this code. If I head back to the hitbox component, we can also declare class name hitbox component here. Then inside of the weapon, instead of checking whether it has the method, we can see if it's a type of hitbox component. If it is, we'll pull it out into a variable and call .damage on that. This has the same benefits as before, where we can do control in space to see what the function wants.
Okay, okay. Sick. Oh, what's the thing I'm looking for? String. Health. Okay, sweet. That'll be there for debug purposes. So whenever I punch the box or kill the box will tell me if it is punched or dead. It will also be pretty obvious because if I kill the box, it'll probably disappear. Maybe. I don't know yet. We'll get
Or we
there.
can control click it to see where the function is declared.
Sick. Okay, back up a little. That's on weapon. I don't have a weapon function yet. I have an attack. Is that the same thing? No, you also have an attack. Curly brackets. Is that how you do that? I feel like it's not. I'll focus on that in a moment.
Component. If it is, we'll pull it out into a variable and call .damage on that. This has the same benefits as before, where we can do control in space to see what the function wants, or we can control click it to see where the function is declared.
Good.
And that's actually all we need to do for composition. If I walked up to this cow, I can hit it. I'll also throw together the tree and the crate just to show you how easy it is once you've got these nodes set up. I'll start by dragging in a health component and then a hitbox component. And inside of the health component, I will set the health to 30. And inside of the hitbox, I will drag in the health component. Then of course, I'll add a shape to the hitbox, give it a capsule shape, and fit it to the tree. Then of course for the crate, we can drag in a health component and a hitbox component. I'll attach the health component and set the HP.
Wait, that means punching box should have its collision shape back. Let's put it over here. Right? Right, because that's the mesh, that's the collision. Boop. Okay, sick. Convex. No, I think I'm just going to make it a new box shape. And then scale it around a little. It's not quite the jankiest. We take those though. It also doesn't have to be perfect, and I need to remember that. So for the purposes of this is probably good enough. Yeah, that's good enough. Okay, sick. Nah, that's probably good.
P to 20. Then I'll add a new collision shape of a rectangle. And just like that, if we go in the game, it takes 3 hits to kill a tree, 2 hits to kill a crate. Hopefully this shows you how powerful composition can be. Of course, it isn't one size fits all. Sometimes inheritance is better, sometimes composition is better. But of course, that's how everything is in game development. Hopefully this makes game development easier for at least someone out there. And as always, have a good one.
Sick. How long have I been at this? Like, 2 hours? Alright, brain, work with me. There's just a little bit of stuff that I still have to do. Doing a big think. So that means when hitbox.damage gets called, it passes the damage to the health component, and then the health component handles the math. So now all we need to do is find a way to transfer damage to the hitbox. So I'm gonna save these. Uh, It's because I have an element type that I don't actually need. So I'm gonna get rid of that for now. Save. And now attack is working. Okay, cool. We'll worry about adding elemental damage types later. I don't really want to mess with that just yet. But punching box now has, well, stuff. Save. Yes. Okay, so now over here, I should be able to take characters, enemies, take a punching box and just slap it like right there. Are you small? You're a little small. I kind of want to make you bigger. Wait, where did you go in the... Wait. Neck, camera, okay. Not nav region. I didn't stick you into... Oh, here you are. Okay, so punching box scale. Good enough, I guess. Up to the middle. Make it fit, sorta. There. Save scene, lobby test. Does that make you bigger? Delete the node. Yes. Put a punching box back here. That should theoretically make you a little bit bigger. Well, you are a little bit bigger. But I can't heckin' touch you, and neither can... Why not? That's a concern. You should have your own stuff. Delete that node. Yep. Paste. Okay, so theoretically this should be collidable, maybe. Save scene, labby test. Test play. Yep, I can collide with that all right. And so can Forstet. I don't know if Forstet can actually, like... Forstet can't walk around it, but it should be fine. Okay. So now we can run into it. Awesome. Okay, so character should have a health. Oh, wait. No, there's a special way that I'm supposed to save this, huh?
Reference to the damage functions. Add a new node 2D to the enemy's health, and inside of the ready on the enemy, we'll add a new area 2D object and call it hitbox component. You may notice a warning about the shape, but we'll get back to that later.
Right.
We'll attach a new script to it. We'll start by exporting a health component variable, then add a damage function, also passing an attack like before, and then we'll check if the health component exists. If it does, we will call .damage on it. And the health component variable can be set in the inspector, like so. One thing I don't really like about this is we can attach any node 2D to its health component variable. And for example, if I attach the sprite 2D, this would crash because sprite doesn't have a damage function. So instead, one thing we can do is inside of the health component, we can declare a class name health component. Then instead of just using any node 2D, we can specify that we want specifically a health component. Then inside of the inspector, you can see that it only highlights things that classify as health components. It's also nice because this gives us IntelliSense. So if I do control space inside this function, we can see what it expects. Or if I control click damage, it will take us to the declaration. Let's go ahead and save these off to their own branches as health component scene and hitbox component scene. One thing you may run into is if you previously assigned health.
Save the branches. Create new folder. Components. I see. Delete the node. Okay. Save scene. Paste the node. Punching box should theoretically still be fine. Maybe. Oh, wait, no. Delete the node. Okay. Paste the node. There, now you have a shape. What's wrong with this? Yeah, I don't really care about that. We're fine. Alright. Hitbox component can heckin' go. So you need a health component attached. Now you do. Save that. Now you have stuff going on. All right. Suppose I don't need Aries. I'll mess with the debug menu later. Oop, that's not what I wanted. Okay. I was up to something. I remember. Go down into components. We're going to need a health component and a hitbox component on the character. Copy that. Hitbox needs a component, so paste it. Hitbox health. I want to make the max health 200 for now. Okay, sick. I'll remove those later. They're just for testing, just to make sure it all works out. Let's see. I've been at this for like 2.5 hours. Not quite done yet. I want to be able to kill this punching box first. How am I going to do that? I'm going to add a child node. It's going to be a raycast. I really just want to get this like working. So we're going to stick this basic attack here, right? Go into script. I guess I could just boop. I want to put it in script. There. Create. Okay, so I don't need any of this. All right. So now we have a sidearm. Okay, let's go into 219 Godot nodes.
Kinder Bueno White Chocolate, the crispy, creamy summer road trip treat. Life gets bueno.
An enabler enables the node when it is seen by the camera. The grid map node. A grid map is basically a 3D tile set.
Stop. 3D nodes. Recast.
Your game. The Raycast 3D. The Raycast 3D node shoots out a ray in a given direction and reports on whether it hit something and what it hit. It's great for a lot of uses, but it's most used in shooting mechanics and interaction mechanics. The Shapecast 3D. The Shapecast 3D works the same as the Raycast. It's a mesh of all the services that can be walked on and how they can be connected. The navigation agent 3D can then traverse your map in a natural and efficient flow. I personally had great results using the nav meshes with Godot, but they're still marked as experimental, so they might change in the future. Keep that in mind. The Occluder Instance 3D. The Occluder Instance 3D node can be used to improve performance by hiding objects that aren't visible to the camera. Please take note that the Occluder is recommended to be used on static objects, as moving the Occluder Instance 3D will trigger a recompilation that can take several frames. It is also recommended to use them in closed or semi-closed areas, as in large open areas. LODs and visibility ranges are recommended to improve performance. The Path 3D and Path Follow 3D. These are super fun. I didn't know about them yet, but they can be used to create 3D paths or 3D curves and bind a node to this path. They're great for setting up small animations and quick organic flows within your game. The Raycast 3D. The Raycast 3D node.
Back to normal speed.
Shoots out a ray in a given direction and reports on whether it hit something and what it hit. It's great for a lot of uses, but it's most used in shooting mechanics and interaction mechanics.
Nice. Okay, so from its origin to its target position, that finds the closest collision object along its path. If it intersects any, this is useful for a lot of things, such as okay. How do I want to do this? I want to Well, first things first, I think I actually want to make this a child of the camera. I also want to figure out which way you're shooting straight up. Oh, no, that's not acceptable. So you're a child of the camera. I want your position to be the camera. I think that'll do it. Yeah, there we go. That should make it basically the exact middle of the camera pointing straight or something. And that's actually exactly what I need. Okay, so back to the script. So that means basic attack should be rotating with the camera, right? Should I push it forward a bit? I think I should push it forward a bit. So that you're just not so that you're not secretly making contact with yourself. Good. 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 Okay. Back to basic attack. What's the command? Get collider. Project settings, input map. I need a cast. Cast needs cast needs to be left mouse. Okay, so character does unhandled input. Make a func, collate. Func attack, I'm thinking. Project settings, cast. It should be cast. Okay, based off of this thing, let's see. I think I should use an input, huh? if event is oh, if event is action cast. Okay, that's what I should be using. Needs to be that. Okay. Then we gotta check whether or not basic attack get collider. Variable target get collider. I do also casually want a export far range. It has to be that long. Okay, so if the event is cast, then make a variable called target, which is the thing that the raycast hits within range. So I want to check with another if statement. Target dot over in forStet we have a way to check how far. Yeah, forStet dot distance to target. Okay, so oh wait, no, distance to target is something that is determined by yeah, okay. So we need to establish how far it is. Does raycast already do that? Object get collider constant. So that's actually an object. Raycast. That's a vector 3. So I should use equals. Get collision point. So now this is a, what is this? This is one of these. This is a vector 3. So for for example, nav is a vector 3, I think. No, nav has a vector 3. Yeah, nav has a vector 3, chases is a vector 3, direction is vector 3. It establishes some things. I think. Func input. So input needs to be no, that returns like where it is and not what I'm looking at. That's not what I want. Hold on. So back to Raycast, close that. So I don't even want this. This is wrong. Okay, let's see. Get collider. The target is now an object. Okay, cool. So that means I can check to see if target is within range. Mm-hmm. Okay, so you have a variable called health, which is a health component. Checks to see if this has health, and if it does, damage it. Neat. Okay. Variable target, collider if target hitbox component. Then I can call damage. Attack needs damage, which is an int. Does that make sense to you? How come this doesn't update that? Why is it like this? Also, does that even work? No, I think that'll crash, actually. That should work, theoretically. Okay, so what do I call damage? Do I just call damage? Function attack not found. Oh, because it doesn't actually have like real damage. Okay. The shit. Has node. Does that make sense? Oh, target dot has node. Okay. So I have to call its damage type. And I need to pass an attack to it. Which means I need to declare damage as an attack. And attack needs okay. Does that make sense? I think that makes sense to the game. There's no if over there. Oh, y'all have been saying stuff. Let's see. Person's voice sped up reminds you of the end of any commercial with medicine. Oh, yeah. You're talking to this Valve meat writer. I'm going to disregard the rest of that. I have no interest in that sort of drama or drama in general. Not even the slightest bit. And no, I'm not sorry. Target has no hitbox. I should probably pass. Get collider as an object. An object is all different sorts of stuff. Game dev nice. You don't understand this code at all. Yeah, it's GDScript. It's a little bit weird. Almost, but not quite Python. I think. Here.
Inheritance and composition
Shut.
that every enemy and every object boxes for every single object. Inside of the scene, you can also set up, and the last thing I'll do is set up my weapon to attack a hitbox. So for this, I'll check whenever we collide with an area, we'll check if it has the function damage.
Mm-hmm. Do we have something similar? Because if we do, I feel like that would be way better than this.
Damage, and if it does, we'll construct a new attack like before and call the damage
Ah, I see.
function passing in the attack.
If area has method damage, attack, or makes a new attack. Okay. Establishes all the things that attack needs, and then passes this attack to the area damage function. Okay. So, checks if target has node hitbox component. Damage does equal 10. Alright, so oop, that's not what I want. Okay, so it goes there. All right. Equals damage. Although I feel like I should be checking a bit more. Can't use anything other than Python and Java or JavaScript. Ah, I see. It's a little bit weird in interfaces with a couple of C languages. I don't fully understand it. I'm learning as I go, I'm not gonna lie. How do you pass it to if area has method damage? Has method, huh? Should I be using had method? Has method? It should be... Let's see, a target has an object. I feel like I should be checking to see if get collider returns the correct object. But I guess this is checking to see if it has damage in the first place. Although I see now why I checked for node. I want to see if it has a hitbox. Ooh. I should probably signal it, or no, wait, how do you do it?
We can also do something neat with this code.
On hitbox area entered assumes that it's probably a hitbox already, or something. I wonder if I could put a nested function inside this. I think coding is really cool, but definitely not for you. You think if you're building or making something, you need to be able to use your hands and feel it? I guess that makes sense. Get collider is an object. Oh, it's not checking to see if it's a node. Okay. Mm-hmm. Not helpful.
How's it going, everyone? My name is Isaac from Shaft Games, and today we are going to look at doing a hit scan weapon as quickly as possible. We're going to try to keep this as brief as can be. If you are interested in learning more about creating a hit scan weapon, I've got a full tutorial series on creating an FPS manager. I recently put out an episode on how to do hit scan weapons with that, but there's a lot of context, so you need to follow it. And I thought it would be good to put out a shorter video that sort of took you through how to do this if you're just looking to quickly learn how to use the physics ray query parameter function and make a hit scan weapon. You don't want to mess around with resources, animations, and learning how to swap weapons and all that kind of stuff. You just need to know how to do physics ray query parameter hit scan weapon. This is a tutorial for you. Not a lot of dependencies here. I've got a kinematic body with the camera movement. Also got a full tutorial on that if you're looking to learn how to do that. Other than that, we've got some terrain that's labeled as terrain. It's just a green square. And we've also got another static body here labeled as enemy that we are going to use as our target. Other than that, let's get into creating this hit scan weapon. The hit scan can really be on any 3D node. As long as it's extending spatial, you will be able to do a raycast from it. I'm going to use the camera because it's just a little bit easier, but this can pretty much be performed on anything that extends spatial. So I'll create this script here. We'll just call it main camera. And I'll delete everything that is on this script and we'll start fresh. I'm going to create a variable here called ray range. I'm going to set that to 2000. This is going to be the range of the raycast. The next thing we need to make sure that we've got in our function is the input function. So I'm going to type func.
In Python, it would just use inheritance and go with it, though you're working with hitboxes, and my project was just a 2D movement and defending. It's an entirely different thing when I thought I understood it. Yeah.
Underscore input.
It's weird.
And that'll automatically fill with the event variable there being passed in. This is a built-in function inside of Godot, and you will need to have a input set up. So I'll come up to project settings. I'll click project settings. Just come over to where it says input map. I've got something set up here as shoot already, but I'll delete that and I'll add a new one called shoot. Click add, the little plus button, and it can really be anything, but I'm gonna make mine the left mouse button. I press OK, and we'll close out of this. Type if event.isAction pressed, and we'll make it shoot, semicolon. I'll just type pass here while we create our next function. Okay, so I'll create a function called get camera collision. It's not going to take any variables, and we'll just come down here. The first thing I need to get is the center of the screen, so I'll create a variable called var center, and I'll make that equal to the viewport, so I'll type get viewport.getSize, and I'll just divide that by 2. Okay, so the next thing we need is the ray origin, so I'll create a variable called ray underscore origin, and that will be equal to project ray origin, and it takes a vector 2, which will be the center. The next variable I'm going to create is ray underscore end. I'll make that equal to ray underscore origin plus project ray normal. That also takes a vector 2. I'll make that the center. But this time I'll multiply it by our ray range. The next thing we need to do is create our physics ray query parameter 3D. So create a variable called new intersection, and I'll make that equal to physics ray query parameter 3D dot create. And this will take our 2 variables from earlier. We'll pass in the ray origin for the from and our ray end for the to. That's really all we need. Now that we've done that, we can actually do a raycast. We can create a variable. I'm going to call my...
Whoa. Okay. Hold up. What's the name of the thing that I'm making? It's a recast 3D.
The only bag that folds over and stays open. Ziploc. Unlock life.
It's so easy to get your windshield replaced using Safelite. Tell the people why you haven't done it already, my man. Let's start it off as...
Raycasting is one of the most powerful tools found in modern game development. Almost every 3D game you've ever played utilizes it to some degree, whether that's Mario or Skyrim or even Halo. Its versatility has enabled game developers to create all sorts of different game mechanics that extend across multiple different genres. So what exactly is raycasting? In the case of Godot would be the physics body. There's other things that can go forever until it hits something. When it does, relative to a certain location or object by casting a ray and seeing what it intersects with. In more human terms, imagine you have a laser gun and you fire it off. That laser will continue to travel forever until it hits something. When it does, the laser gets a bunch of information about the impact, like the location it hit and the object itself, which in the case of Godot would be the physics body. There's other things it can tell you, but we won't worry about them for right now. Those are the 2 most important ones. It sounds pretty simple, but that simplicity is what makes it so powerful. Game AIs use it to simulate vision, animation systems use it to dynamically align characters' feet with the ground, shooters use it to simulate high-speed bullets from guns, and there's about a million other applications you can come up with. My favorite example is probably Mario Galaxy, which uses raycasting to align Mario with the ground of the planets he walks on, creating the game's gravity-defying movement system. Almost every single time you're working on a 3D game, there's going to come a point where you want to gather information about about the world around you that you don't know beforehand. Raycasting is exactly what lets you do that. Most engines offer raycasting support right out of the box, and Godot is no exception. Godot gives us two options to raycast in 3D, the raycast node and directly using the physics server, which we'll get more into that later. Both have their strengths and weaknesses. The raycast node extends spatial, so you can the raycast node and directly using the physics server, which we'll get more into that later. Both have their strengths and weaknesses. The raycast node extends spatial, so you can move it and rotate it anywhere in your scene. It has a parameter called cast2, which will let you decide what direction and how far the raycast will travel. In order to actually fire the raycast, you can either call the force raycast update method, or set its enable property to true, in which case it'll fire a new raycast every single physics frame. To get the results of the raycast, use one of the methods available on the node. Each bit of information the property to true, in which case it'll fire a new raycast will travel. In order to actually fire the raycast, you can either call the force raycast update method, or set its enable property to true, in which case it'll fire a new raycast every single physics frame. To get the results of the raycast, use one of the methods available on the node. Each bit of information the raycast.
Okay, so I have to actually cast the ray. All right. That means basic attack, or that needs to be off. It is not enabled. I don't want it to be firing all the time. I only want it to be firing whenever I press cast.
Cast collects can be accessed using the corresponding function, like get collider for the physics body we hit, and get collision point to get the position. There's a few other methods which I'll put on screen now to access some of the additional information that the raycast collects that I haven't talked about yet. Additionally, there's the is colliding method, which lets you know if the raycast actually hit something or not. Here's a little scene I made with a cube and a raycast node with its name.
Okay, so let's see.
Property check and get collision point to get the position. There's a few other methods which I'll put on screen now to access some of the additional information that the raycast collects that I haven't talked about yet. Additionally, there's the is colliding
If is colliding, target is get collider, target there's going to be an attack, makes a new one, determines damage, target dot whatever the heck.
method, which lets you know if the raycast actually hit something or not. Here's a little scene I made with a cube and a raycast node with its enable property checked on, so its raycast data automatically updates. The script on the cube makes it change colors if the is colliding method on the raycast node returns true. So if the raycast hits something, the cube changes color, as you can see when I move the sphere up to where the raycast hits it. The length of the raycast is really important. If I change the length of the cast2 property, moving the sphere up doesn't trigger the color change anymore. I have to move the sphere really close to the cube, in which case the raycast will finally pick it up. The raycast node is great when you always want to raycast from the same relative position, like the muzzle of a gun, but it can be really inconvenient to use when the position and rotation of our raycast is constantly changing, or if we want to do a raycast specifically from one point to another point. This is where Godot's second method of raycasting comes in, directly using the physics.
Okay, slow down. Slow the heck down.
Great when you always want to raycast from the same relative.
Okay, so I don't want it to cast forever. Let it test this thing. undo. Can I like determine target position? The raised destination point relative to position. Can I determine that? Doesn't look like it. That also doesn't look like it. Weird. Anyway, back to this.
Position like the muzzle of a gun, but it can be really inconvenient to use when the position and rotation of our raycast is constantly changing. Or if we want to do a raycast specifically from one point to another point, this is where Godot's second method of raycasting comes in, directly using the physics server. Without going into the nitty-gritty, Godot's physics engine is represented as a server where all the information about the game's physics world is stored. You can access it using getViewport.world.directSpaceState. Here I store that in a variable called space. The server has a method on it called intersectRay, which takes two primary arguments, the start point of the raycast and the endpoint. So think of this as shooting off our ray/laser off from the start point, and it moves towards the endpoint until it either A, reaches the end, or B, hits something, in which case it tells us about it. The intersectRay method also has some optional parameters that are helpful, such as exclude, which allows us to define an array of objects we want the raycast to ignore. Going back to the laser example, would be like telling the laser to just move right through all the objects in the array like they don't even exist. IntersectRay returns a dictionary containing a lot of different values, which you can see on the screen right now, but the most important ones are the ones we talked about earlier: collider, which is the object we actually hit, and position, which is the location where the raycast hit. Use a script that uses this method to determine line of sight.
Player physics body.
Method, which lets you know if the raycast actually hit something or not. Here's a little scene I made with a cube and a raycast node with its enable property checked on, so its raycast data automatically updates. The script on the cube makes it change colors if the...
Let's see. I'm ready for a raycast, which is a raycast. If check is colliding, target equals check dot get collider. Okay. That's got to be an object. Target get node. I want to check to see if you have a hitbox. No, I want to check to see. This needs to be an if. Does that work? I assume yes. Ooh, that's weird. Okay. Boop. Cannot infer the type of target variable because value doesn't have a set type. If target.getNode has a hitbox component, create a new attack with damage, right? And then target dot oh no, I'm out of time. Oh no, I'm out of time. Hang on. It was like right on the tip of my tongue. Also, how come this doesn't work anymore? Should return an object. So this is an object. Get collider returns an object, yeah. Do I have to establish this as an object? It was working just a moment ago. Is that all I had to do? What if I just do this? Does that work? It isn't screaming at me, so I'm just going to assume that it works. Technically, I'm checking to see if it returns an object, and if it doesn't, it would return a null. But since I'm checking to see if it isn't a null, it won't return a null if it gets this far. So we should theoretically be fine. So target.getNode hitbox component. It checks to see if target has a hitbox component, and if it does, makes a new attack. And then target dot hitbox component and hitboxes have a function called damage. Dot. Can I do this? So it sends it an attack. This theoretically should work, right? Yeah, so hitbox component has a function damage, which is an attack. So theoretically, if we run this, it should sort of work. Let's run through this. Let's see. It goes off when we do an input, checks to see if it's cast. If it is, it does a force recast. And if it's colliding with something, checks to see, or it establishes a variable target, which is check.getCollider, which should be the thing that check hits, or the basic attack hits with the raycast, right? And then if the target has a hitbox component, this returns as a bool, right? Target get node. Then it establishes a new attack, determines the damage of the attack, which is 10, which we can mess with outside of the script. And then it gives attack to the hitbox component of the target. The hitbox component has a function damage. No, that doesn't feel right. I'm gonna var hitbox so hitbox damage, and then we'll give it attack. I think that'll work, probably. So we're going to save that. And for better or worse, I'm just going to test this like right now. Play. Does it... Oop, it crashed. Errors. Variable range is the same name as a built-in function. We're not even using it. Basic attack on 13. Node not found. Okay, so I think the first time, I think here it missed. Oh no, it didn't actually, it couldn't find punching box's node. But punching box has a hitbox. Whatever. We're pretty much done here. I gotta get ready for work and stuff. Y'all have a good one. Drink food, eat water, love yourself. There's links and stuff in the description you should totally go and click. And have a good night.